Hi everyone, how's the preparation for boards going on? So from today we're starting a new 30-day series of solving the section A of a sample paper each day with quick tricks so that you can achieve the section A real quickly. Now, let's get started. The first question on screen. The probability of getting a bad egg in a lot of 400 is 0.035. The number of bad eggs in the lot is. Now, I let the number of bad eggs to be x, so thus the probability becomes 400. And the actual probability which is given is 0.035, which is nothing but 35 upon 1000. Now, simplifying, 2 zeros to 2 0 cancel. 2 twos are 4, 2 fives are 10, 5 sevens are 35, 7 twos are 14. We get the answer as 14. Moving on to the next question, wherein a quadratic equation is given and we have been told that it has no real roots. Now, for a quadratic equation to have no real roots, we know the condition is that d or b square minus 4ac, the discriminant, should be less than 0. Solving with this, we get b square minus 4ac is less than 0, or we can even say b square is less than 4ac, just transposing for simplicity. Now putting in the values from the given equation, we get 2 times ac plus bd whole squared is less than 4 times a square plus b square times c square plus d square. Solving further, we get 4 times a square c square plus b square d square plus 2 b c d less than 4 times a square c square plus b square c square plus a square d square plus b square d square. Hmm? 4 and 4 get cancelled. A square c square cancels with a square c square. B square d square cancels with b square d square. We are left with 2abcd is less than b square c square plus a square d square. Taking this 2abcd to the other side, we get the formula for the whole square of bc minus ad square. Now, what this implies is that BC minus AD is actually either a positive number or a negative number. It is not zero. So, in both cases, we can effectively say that BC is not equal to AD no matter what. If BC is greater than AD, then BC minus AD is a positive number. Its square becomes greater than zero. If BC is less than AD, then BC minus AD becomes a negative number, but again, its square becomes a positive number. So, it's greater than zero. And let's take a look at the options. Here we are. The answer is option C. AD is not equal to BC. Moving to the next question, it says that the volume of the largest right circular cone that can be cut out from a cube of edge 4.2 centimeter is. Now, for the volume of a cone, we need two things, the radius and the height. Considering that this has been cut from a cube, we know that the height is going to be the edge or the side of the cube, which is 4.2 centimeter, because we have cut the largest possible one. So we're going to keep the height the maximum we can. And as for the radius, it becomes half of the side of the cube, and thus it becomes 2.1 centimeter. Now putting in the formula for volume, we get 1 by 3 pi r square, just converting it into fractions for simplicity, times h. Hmm, Changing even this one. Now, when we solve this further, we get the answer as 19.4 centimeter cube. You can try this out with 121 being cancelled as 3 times 7, and then the multiplication goes simply. Hmm. Moving on to the next question, we have, if one root of the given quadratic equation is 0, is 1, then the other root is. Now here we have to imagine quickly that there are two roots to a quadratic equation. One we call as alpha and the other we call as beta. Now given that alpha is 1, it simply means that when we find the product of zeros, alpha times beta, it is basically 1 times beta or beta only. Thus, the other 0 is actually equal to the product of zeros, and the product of zeros is c by a. We put in the value from here. C is actually c times a minus b. and A is A times B minus C, and this is the other 0. The answer is option number B. Moving on, we go to the next question, which says the 11th term of the given AP is. Now, to find the nth term, any number of term for an AP, we need two things. Firstly, the A, which is minus 5, given first term. So, and we need the D, which is the common difference. Finding the common difference here, we get the common difference actually plus 5 by 2. Now, 11th term. For any nth term, we can use this trick that if you have to find the 11th term, you actually do a plus 10d, which is basically putting in the formula only a plus n minus 1d. So just reduce the n by 1. Here we have to find a plus 10d. Hmm? A is minus 5 plus 10 times 5 by 2. 5 5s are 25, 25 minus 5 is 20. The answer is option number D. Moving on to the next question. The distance between the two given points and one of the points is the origin only, 0, comma 0. We know the distance formula is actually x2 minus x1 whole square plus y2 minus y1 whole square all under root. But here our work is much simpler because one of the pair of coordinates is actually 0. So putting it in a trick, we can simply square this x, which means a minus b square, and square the y, a plus b square, because no matter what, subtracting 0 from these does not make a difference. Opening up the squares here, we get a square plus b square minus 2ab plus a square plus b square plus 2ab plus 2ab minus 2ab cancel, and we get option number B, root of 2a square plus 2b square. Moving on to the next question. The zeros of the quadratic polynomial this are. Now we have to tell about the signs if both are positive or negative. Now here, as you can see, we are going to do some of the thinking part here. No need to solve it in real. It is actually the sum of zeros is minus b by a, which means b is 88, a is 1. So the sum for these two zeros, alpha plus beta, is minus 88, right? And the product is C by A. So it's 125 by 1, nothing but 125. Now think about this. There are two numbers. Their product is positive, but their sum is negative. Now, what should be the signs for these two numbers? They should be two negative numbers. Just imagine, let's say two numbers, minus 2 and minus 3. What's their sum? It's minus 5, but their product it's 6. So the to get a sum as negative and the product as positive, we actually need the two numbers to be negative, and thus our answer is both negative. You can check out that it's not as both equal by finding the discriminant, which is not equal to 0 in this case. Moving on to the next question, which is about the BPT or basic proportionality theorem. We have been given two pairs of parallel lines, and we need to tell which of these following relations is correct. Now, considering the first set of parallel lines, this one, DE and AB. What can I say about the two triangles that have been formed on these parallel lines? I can say that DC by AC is equals to EC by BC. Right. Now, I'll consider another set of lines, which is EF and DB. Now, considering the triangles made on them, what can I say? I can say FC by DC is equal to EC by BC. Now, using these two equations, I can infer that in reality, these two are equal, which means DC by AC is equal to FC by DC. My bad. FC by DC. Now, cross multiplication, it becomes DC square is equal to FC into AC. Thus, we get option number D. You can check out the other three options as option out method. All of them are incorrect. Moving on to question number 9, which talks about tangents. Now, here we are given the length of particular tangents as 4, this whole is 7, this is x, and this one is 3. We have to find the value of x. Now consider this. This particular length and this particular length, they are going to be equal because they are tangents drawn to a circle from the same point of contact. Thus, this part is 4 centimeter. Now we given the hole is 7, this part is 4. So the rest, the remaining is 3. And again applying the same property, we can say that this part is also 3. Now coming from the other side, we have 3 centimeters given here as well, which means same property again. This part is also 3. Now what is x? X is 3 plus 3 centimeter, which is 6 centimeter. Option number A. Moving on to the next question, which is again on tangents. We are given two concentric circles with radii 5 centimeter and 3 centimeter. So just marking it here, 5 and 3. From an external point, PA and PB are drawn, which basically means these are two tangents. PA is 12 centimeter and we have to find PB. Now look here, this is a right angle triangle formed with OA and OAP as the sides. Putting a Pythagoras theorem here, we get OP as 13 centimeter. Now again we have a right angle triangle OBP, and thus we can find the length of BP as BP square is equals to 13 square minus 3 square. 13 square is no, 13 square is 169. 169 minus 9 is 160. So BP is actually root of 160, which is 4 root 10. Option number D is the correct answer. Moving on, we've achieved half of the section A. Let's go. The next question is, if A sine theta plus B cos theta is C, then the value of A cos theta minus B sine theta is. To do this, we are going to square the given relation we have in front of us. So when I square this particular equation, I get A square sine square theta plus B square cos square theta plus 2AB sine theta cos theta is equal to C square. Now I am putting sine square theta here in as 1 minus cos square theta and cos square theta as 1 minus sine square theta. Hmm? We'll get to know why this has been done, but you'll need to do this to get here. Hmm? Now when I open up the brackets, I get a square minus a square cos square theta plus b square minus b square sine square theta plus 2ab sine theta cos theta is equal to c square. Now what I'll do is I'll keep the b square, a square and c square to the LHS. So we get a square plus b square minus c square, and I transpose the rest of them to the right hand side, which becomes a square cos square theta plus b square sine square theta minus 2ab sine theta cos theta. Hmm. Now this is nothing but the formula of a cos theta minus b sine theta, the expression we wanted, whole squared. Thus we get root of a square plus b square minus c square is equals to under root a cos theta minus b sine theta squared. So root and square gets cancelled out. And here we have, let's check out the options. Yep, option number A, we get our answer. Moving to the next question, which is if the HCF of this and this is 18, then the LCM is. Now we have a simple formula of number 1 into number 2 is equal to the LCM into HCF. Putting that here, we get 72 into 234, the two numbers, is equal to HCF into LCM. Now cancelling 18 ones are 18, 18 fours are 72. Multiplying, we get the answer as 936. Moving on to the next question. The tops of two towers of height x and y. Okay, so I am drawing two towers here. Firstly, this is the ground. I am drawing two towers. This one is X, this one is Y. Subtend angles 30 degree and 60 degree from the center of the line joining their feet. Hmm. So this is the center, let's say. Hmm. Now I am joining the tops of these towers, which means that this angle is 60 degree and this angle is 30 degree, as has been given to us. This is 30 degree, this is 60 degree, and we have to find the ratio of x is to y. Now here we know that this point is the midpoint. So this is also some length, say A, and this is also some length A. Now putting the value of tan 30 here in this given triangle, we get x by A is equal to 1 by root 3, or I can say x is equal to A by root 3. Now in this particular triangle, tan 60 degree is y by A is equal to root 3. Hmm, or y is equal to a root 3. Now to find the ratio, we divide the two, which is a by root 3 divided by a root 3. This gets cancelled out. This is multiplied to it, and the ratio is 1 is to 3. Moving to the next question, we have in a circle of radius 21 centimeter and arc subtends an angle of 60 degree at the center. The area of the sector formed by the arc is. Hmm, we have to simply find the area of the sector. Theta is given, radius is given. We put it in the formula theta by 360 times pi r square. Cancelling out, we get 21 times 11, which is 231. Option number A. Moving to the next question. A piece of paper in the shape of a sector of a circle is rolled to form a right circular cone. The value of angle theta is. Now, here the main concept we're going to use is that the area of this particular sector is actually the CSA of this particular cone, right? And the slant height of the cone here, it is nothing but the radius of the sector here. Hmm? Now we're given the radius here as 5 and the height as 12. Using Pythagoras theorem, we can find out the slant height as 13. Now thus the radius here becomes 13, and we have to now equate the two areas. The area of this sector being theta by 360 times pi r square, is 13 times 13, is equal to the CSA here, which is pi times r times L, which is again 13. 13, 13 cancel, pi, pi cancel. We have to find the value of theta. So just multiply, just transpose rest everything else there, and we get the answer as, we have to find the value of 30. So the answer becomes option number A, 5 pi by 13. Moving on, a letter is chosen at random from this particular word association. Find the probability that the chosen letter is a vowel. So first count the total number of letters in this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total is 11, and the number of vowels A, O, I, O. 5. 5 by 11, option number C. Next question. Two dice are thrown simultaneously. The probability that the product of the numbers appearing on the dice is 7. Now, 7 is itself a prime number. Consider this. You can obtain 7 by multiplying two natural numbers only if the two numbers are 1 and 7, or say 7 and 1. Is it ever possible to get a 7 on a dice? Not. So this is an impossible event. You can never get the product as 7. You can try listing out all the possibilities and you will end up with no favorable outcome. So the answer is 0. Moving to the next question. In a data, we are given the L, H, F1, F0, and F2, and we have to find the mode. So simply just put it in the formula. The formula for the mode is L plus F1 minus F0, which is 4, by 2 times F1, 14, minus F0, 3 minus 6 times height. Simplifying further, 40 plus 4 by 5 into 15. 4 threes are 12, 12 plus 40, 52. Option number C. Moving to the next question. In the given figure, a sphere is inscribed inside a cylinder. The surface area of the sphere is not equal to the CSA of the cylinder. Now, the surface area of the sphere is straight away 4 pi r square. Hmm? And the CSA of a cylinder is 2 pi r h. We have been asked to compare these two indirectly in this assertion and reasoning. Now, here consider this. This is also the radius of the hemisphere, and this is also the radius of the sphere. Hmm? Now, doesn't it mean that the height of the cylinder in itself is 2r? Now, if I put 2r here instead of h, I get 4 pi r square, which is exactly the same as this one. So, the assertion is false. Moving to the next, the surface area of a sphere is 4 pi r square, which is true. Option number D is correct. A is false, but R is true. Last question. If an minus 1 is not independent of n, then the given sequence is an AP. And the common difference D is constant or independent of n. Now, in this case, R is true and A is false again, because if you have to get an AP, this means that this is the product of two consecutive terms only, and thus we get that this has to be actually the common difference. And if the common difference is not independent of n, if it keeps changing, then we cannot get an AP. A is false, R is true. Option D is correct. Hope you like the tricks given in this video, and visit the channel of Alwin Academy for further explanations. And you can share this with all those who are preparing for 10th grade this year. All the best. See you in the next video. Thank you.